Hey y'all, welcome back to Math Rescue. I'm Andre, your certified math coach. This video, I'm going to show you how to solve a linear quadratic system algebraically using substitution. Now, I know these problems look crazy at first. You've got one linear equation, one quadratic, and a bunch of x's and y's everywhere. But they're really just early quadratic skills in disguise. Once you plug that linear equation into the quadratic, the rest is smooth sailing. It's just a regular quadratic equation waiting to be solved. Stick with me. I'll break it down step by step. Let's talk about it. Alright, so this question says solve the system. The first thing I notice is that I have a quadratic function on top. I know it's a quadratic because we have the infamous x squared term. We have a linear on the bottom. And lucky for me, the quadratic is already solved for a variable. This purple box is already set equal to y. And I notice that I also have a y here in the linear equation. And so I can use that to do a substitution. Let me go ahead and substitute the purple. So I'm going to say 3x minus 2 times y. I'm going to leave a big gap to plug in y there. And all of that is equal to 4. So in this case, I'm going to write y, and I'm going to represent y as 2x squared minus 5x plus 3. And now I have a nice solvable equation for x. I'm going to go ahead and do distributive property. We're going to multiply all three of these terms by -2. All right, let's start. -2 times 2x squared gives me -4x squared. -2 times -5x gives me a positive 10x. And -2 times a positive 3 gives me a -6. Next, I'm going to combine like terms. So I have a 3x and a 10x. Three x plus 10x makes 13x. And then my very last step is I want to zero out this quadratic. So I'm going to subtract 4 from both sides. End up with -4x squared plus 13x minus 10 is all equal to 0. And now we're all set to go ahead and start factoring. So I'm going to set up my x grid to factor. We want to add to 13x. And we want to multiply to the product of the leading coefficient and the constant. So in English, that means we want to multiply to -4 times -10, which is 40. We want to find two numbers that multiply to 40 and add to 13x. So let me go ahead and think about what those numbers might be. To help me out, what I can do is I can list the factors of 40 and see which could possibly add or subtract to make 13. I get 1 times 40 times 20, 4 times 10, 5 times 8. So that's going to be the one that makes 13. So let me go ahead and record that. 5 and 8. From here, I'm going to use those two values that I found to rewrite my quadratic. So -4x squared. What I'm doing is I'm splitting up this 13x. Instead of 13, it's going to look like 5 plus 8. Right, and then I'll be able to factor by grouping. This is one of the longer factoring cases. If you're like, what the heck is this man doing? Feel free to check out one of my other videos on factoring. I'm going to factor out a -1 here. I get x squared minus, oh, I want to actually do -1x. So I get x minus 5. Over on the other group, on the blue group, I'm going to factor out a 2. When I factor out 2 from 8x, it leaves behind a 4x. When I factor out 2 from 10, it leaves behind a 5. This helped me to notice that I actually forgot to write my 4 in right there, so let me go ahead and fill that in now. Okay. So we are all set here. This looks good. I'm going to factor one more time. I'm going to factor out the parentheses from both of these terms. Here are the two terms. So if I factor out the parentheses 4x minus 5, that leaves behind a -x plus 2. And all of that is equal to 0. Since all of this is equal to 0, from here I could go ahead and use the zero product property. I like to say ZPP for short. So the zero product property lets us set each of these linear factors individually equal to 0, which allows us to finish our solving. For the first linear factor, I'll add 5 to both sides. I get 4x equals 5. And then my last step, we'll divide both sides by 4. And so I get one of my x values, x equals 5 over 4. Same kind of deal over here. Over here, I'll actually, I'll add x to both sides. And so I get x equals 2. All right. Because we're solving a system, we're still not done. We want the full ordered pair where this quadratic function and this linear function are going to be intersecting and backing each other, hitting each other. So what I'm going to do is I'm just going to scroll back to the top, and I'm going to copy our original system. And what I want to do is I want to plug back into the linear equation to solve for y, because the linear equation is probably going to be the easiest to finish solving. So let's check it out when x equals 2. Three times 2 gives me 6, minus 2y equals 4. From here, I'm going to take away 6 from both sides. I get -2y equals 2. I'll divide both sides by -2. And I end up with y equals. So the ordered pair that I got from working with these two would be 2, 1. That's going to be my first solution. Let me go ahead and do the same thing with x equals 5 over 4. So this one has a fraction, but it's okay. We get 3 times x minus 2y equals 4. I'm just going to multiply everything by 4 to get rid of the fraction. Times 4. My first term becomes 3 times 5 because the 4's cancels each other out. My second term becomes minus 8y. And then on the other side of the equal sign, we end up with 6. 3 times 5 gives me 15. Minus 8y equals We'll go ahead and we'll subtract 15 from both sides. And we get negative 8y equals 1. And our last step, we divide both sides by negative 8. And we get y equals negative 1/8. All right, and then so the ordered pair there is going to be 5 over 4 and negative 1 over 8. And there we have the two places where these two functions hit. They can hit twice, they can hit once, or they can not hit at all. So there's kind of three different cases you could run into when you're solving these out. Good luck in math class. I'm Andre, your certified math coach. See you next time.